Question 4. If the interconnection in this figure is valid, find the power developed by the current sources. And if the intersection is not valid, explain why. So first we have to see if the interconnection is valid or not. So let's see. We have two independent current sources, 10 amp going this way, and 15 amp going that way. Sorry, 5 amp is going that way. So 10 and 15, therefore, it's going 10 and 5, sorry, it's going to be 15 amp going this way. So I don't see any contradiction because the voltage source can handle any current, so that's fine. So in terms of voltage, so there's a 100 volt increase and then there is a 40 volt drop, and again any current source can tolerate any voltage, so I don't see any problem. So definitely this is valid. And it says find the powers. Okay, so let's look at each element and calculate its voltage and current and then find the power. So let's name them. Let's say this is element 1, element 2, element 3, and element 4. Okay. Sounds good. So starting from element 1, let's say we have some reference voltages, V1. And how much is V1? V1 is exactly, see, this point is connected to this, and this point is connected to that. And this is 100 volts. So basically, terminal A and if we have terminal A and B, terminal A minus terminal B is 100 volts. So therefore, V1 is exactly 100 volts. It's connected, it's parallel to this 100 volts. So V1 is 100 volts. How much is the I? 10 amp is going that way. So if I want to calculate power, I will remember that if 10 amp is going that way, then if I would like to do the, the convention, the direction, passive sign convention, I will remember that negative 10 amp, therefore going that way. So let's do the power just right now. Power P1 is V1, which is 100 volts, times the current that is going this way, which is negative 1 kilowatts. Okay, so we're done with the first element. Now the second element, this one. Second element, okay, I know the voltage, so P2. Again, I look at the plus minus of 100 volts times the current that is going within the element, which is exactly the same direction as I had before, which is 15 amp. Okay, now let's look at P3. The voltage is 40 volts times the current that enters here, which is in this case 5. Then 200 watts. Okay. Now P4. To calculate P4, I have the current, but I need to find the voltage. Okay, so again here, we can do different ways of calculating the voltage. So as you see, there is a 100 volt here. This is a voltage source. So increase of 100 volts and then increase of 40 volt here. So the whole voltage from this terminal is 40 and plus 100, which is 140. Oh, sorry, 140 volts. Okay, so V3, therefore, we got 40 plus 100, 40 plus 100, that's 140 volts. And this is V4. So V4, we're talking about this fourth element. 140 volt, and P4 is, let's say, the voltage, which is 140 times the current. This is again very, very important. the current that is going this way because of plus and minus sign. So if 5 amp is going up, negative 5 amp is going down. And this amount is 700 negative. 700 watts. Okay, so these are the powers that we have for this all the elements. So let's add them up. So P1 plus P2 plus P3 plus P4. To just see if I did the math correctly or not. P1 is negative 1000. P2 is 1500. P3 is 200. P4 is negative 700. So let's see. Negative 1000 and 1500. So that's plus 500 plus 200 plus 700 and then negative 700, 0. Perfect. So we are happy because it was we have a power balance. So apparently we did all the direction and everything correctly. Okay, and which elements are generating power? So this element P1 and negative, yeah. P4 are generating power, delivering power. And the same is here. And these two elements basically are consuming power. Absolutely. Okay, great.